know. There we go.
This is like the Death Star.
You are.
I don't know. I'm picturing Spaceballs, and we're about to go plaid.
Oh, the ludicrous speed.
Yeah.
That's how we start on all these. I know. I think Google will fix that at some point.
Yeah. Just so you know, Tesla, if you want to spend the extra $10,000, you actually can get the ludicrous speed upgrade on your Tesla S. They're about to they are creating a new roadster. They promise it will go plaid. They have used that phrasing. Yes. Yeah, because the ludicrous speed makes that Tesla about as fast as a Bugatti. It's quick. It's quick.
So you're reading out 4 hours?
We're talking acceleration, not top speed.
Oh, okay.
0 to 16.8 seconds, or something like that. Anyhow, I'm Bart Poulson. I'm Bart Poulson, and you guys have been able to hear me speak a number of times. My day job is as a psychology professor at Utah Valley University, where I actually teach statistics full-time. But I am also a video author for lynda.com on data topics, and I have my own company, DataLab.cc, which also perpetually almost ready to launch with videos, also doing some in-person workshops. We have one going on in about 36 hours at Impact Hub on 150 South. It's just a 4-hour introduction to data science for people who don't know what it is. And then Friday of next week, an 8-hour get up and running with R, in case you ever wanted it, because everybody I work with says, yes, I should know how to use R, but I don't. And so it's sort of oriented towards them. Anyhow, I've recently given talks on planning data science projects and on spreadsheets, the value of spreadsheets. But today I'm going to talk about something slightly more interesting, and that is presenting the results of your analysis. Now, the idea here is that you've done a big project. You've done, you've done your data foo, and you've obtained the data, and you've scrubbed it, and you explored it. You modeled the data, and you interpreted it. You may recognize these as the 5 steps in, oh my goodness, this is, okay, hang on, bugs me. Okay, sorry. You may recognize these as the 5 steps in Hillary Mason's awesome definition of data science in terms of procedural definition. But to quote good old Duke Ellington, it don't mean a thing if it ain't communicated effectively. Your analysis has accomplished nothing if your client doesn't understand it and know how to do something with it. And that's where the human side of data science comes into things. So I'm going to talk about a few things that you need to do. Number one is when you are presenting the results, either in a presentation like this or in a written report, first and foremost is you need to address your client's needs. The idea is they have a goal in mind. They hired you for a reason. Even if you are sort of an internal employee, there still was a purpose for allocating your time to this particular project. And it's important to stay focused on the goal. You guys may remember watching the Lions and the Cowboys games from the playoffs earlier. And what you have here is a classic example. It was a very controversial call because it did not get called for pass interference. When you're playing football and you're going after the receiver, you don't hit him. You go for the ball. And the thing you will always hear in that is the coach say, go for the ball. Because you know what? The ball scores points. You can't get points unless you have the ball. We want the ball. We don't care about knocking the other person down. Stay focused on the goal. So, why did you get hired? Was there a specific purpose? What is the big picture? They may have come in with a very specific question. For instance, I did this project at Utah Data Dive a few months ago, and one of the nonprofits that participated was the Springfield Museum of Art. One of their extremely specific questions was, should we stay open on Sundays? That's easy. That's a yes-no question. Now, they have a big picture in that they are there to bring art to people in Springville in Utah County and try to reach a wide audience, but they have limited resources, like any arts organization. And so they're trying to decide if there was a good return on investment for staying open on Sundays. So that was both the specific question and the big picture. Next, well, I say, did they have a specific question for you? Yeah.
I've got a question on the big picture. What do you find for the big picture, because I completely agree you need to be able to see the whole view. What do you find are some of the common questions you ask companies or someone else to get that big picture out of them? Because sometimes they don't get it. Again, they tell you one specific question. Well, what are some of the things you may say?
This is where, believe it or not, mission statements can actually come in handy. Because nearly every organization has an official mission statement that at least claims to be our big picture. Now, of course, the problem is most of them are so vague, you have no idea what they are, but it does involve a little bit of discussion. And the idea here is, are you trying to reach the maximum number of people? Are you trying to get, like, for instance, the museum? Are you trying to maximize the number of visits, or are you trying to maximize the number of unique visitors? Are you trying to maximize the number of school children, or then maximize the number of adults? How are you engaging? How are you gauging exposure to art? And if they have a mission statement that's at all useful, that's great. Otherwise, you're going to have to follow it up with them, because you have to be able to place it in a context. Because sometimes you can answer a specific question in a way that does not meet their needs, that doesn't further the overall thing. So when you're presenting the results, number one is, if they had a specific question, then answer that question directly and concisely. Where have you at my data dive? We had a problem. The Springville Museum never got a yes or no. What they got was like 30 charts about attendance on Sundays. And I then had to like follow up then with myself and say, okay, the answer is no. It's no. That's what they said. If they have a specific question, answer it, make it so obvious, that they don't have to infer anything. Also, connect your answers to the big picture whenever possible. You want to make this particular policy change because it both accomplishes this one goal and it fits into your overall mission. Okay, that's the idea. Truthfully, it reminds me of something that Nick probably here knows about, and that is, if you're trying to get a job, I'm occasionally on committees where we're hiring new faculty at my school. Well, you know what? People run a job ad. When you apply for the job, make so your application and the job ad correspond. I also work with people who are applying for tenure. And I say, look, we have a tenure document. We have a list. These are the criteria. It's 5 pages long. Everything you supply needs to be in exactly the same order, using the same phrases. You need to go point A, point B, all the way through. You need to do the same thing when you're presenting the results to your client, which, by the way, to back up, it's a good idea to try to get written specific questions from your client beforehand. So you can say, this is what you wanted me to do, boom, 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 boom. Here are my answers, boom, boom, boom. By the way, this is from careerbuilder.com. But I'm sure Nick can tell you a lot more about applying for jobs. Okay. Next point, give actionable advice. Now, I come from a legal background. Actionable means something that you can sue people for, but in the business world, it means something that you can do, right? So maybe you guys read the Lorax once upon a time. And here we have the Onceler who has created his Thneed. And you remember the original reaction. He shows that's the Lorax, shows him his Thneed, and he basically goes, what the hell is that? He goes, it's a Thneed. It's a thing that people need. It's a fine thing that people need. And he actually tries to sell it at first. It doesn't go anywhere because people don't know what to do with it. But eventually it becomes this huge, giant hit once people figure out that there's a purpose for a Thneed. In fact, the point of it is there are many, many purposes. But you don't ever want to be in the situation where you're holding up your little data Thneed to your client and they're going, what on earth is that? So you want to be able to address the question that comes up sometimes. You have all your charts and your things and they go, so what? This happens more often in academic things because you weren't commissioned. You're presenting your research and they sound like, I don't care about your research. You have to say why it matters. So what? What's the point of that? Also, give the next steps. So that is the actionable part. So for instance, with museum, we would say that you should stop operating on Sundays with this one exception, which is when you have major concerts, but you're going to have to promote it in this way to get the people here. And so you tell them what to do. The idea here, again, is people are cognitively overloaded. Make their job as simple as possible by spelling things out in as much detail as possible. So be specific at each point. Do this to this degree, in this manner, at this time, as much as the data justifies it. Also, it gets into the issue of operational definitions. Oh, now you guys, I don't know if people outside of academia use this term. Operational definition, because I'm trained as a psychological researcher. An operational definition is the operations or the procedures by which you are defining the construct of interest. How do we actually know how to count something? So for instance, in psychology, we deal with stuff that's notoriously slippy. How do you define well-being? Now, I encounter the problem, good one, Nick. I encounter the problem of people sometimes throwing their hands up when I talk about psychology, and they go, how can you possibly measure well-being? And my response always, look, just because you don't know how to do it doesn't mean nobody can. I call it the argument by personal ignorance. You need to be able to spell out specifically how can you tell when you have implemented, how can you tell when you've reached your goals. This is how we're counting, branching out to a new audience. How can we tell, how do we define your new market sector? How can we tell when you have reached them in a particular way? Also, recommendations must add value. Something that never comes up in academic worlds, but the added value proposition. Do your recommendations basically cause them to make more money? Are they a more efficient, better run business because of that? Closely related, of course, is any recommendation you have should have a good return on investment, because it costs even to stop doing things. Any of you software developers? Okay, you know how people react when you take away major features? Or even a feature that you thought nobody used, and then they're up in arms. I still remember Apple when they updated Final Cut most recently. People were furious because they said, you just turned it into iMovie Pro. And then Apple had to do a lot of scrambling to restore features that were there previously. So you would think that taking stuff away would make your life easier. And Google, how you start using something that they do and then they kill it regularly. Have any of you been caught by Google killing something that you use? Yeah, I have, more than once. So even removing something, there's still a cost. And so you have to talk about the return on investment of potentially alienating some people or confusing them. But more often it's about starting something new and what are they going to be able to get out of it. And you usually need to be able to calibrate it in terms of specific business outcomes, like this many new customers, this many new markets, this many new products sold in this amount of time. If you have that kind of data, which is going to be a lot more persuasive if you do. Also, remember the 80-20. Now, 80-20, very loose rule of thumb. You guys, I know I've mentioned this like 3 times. 80-20, or the Pareto principle, is the idea that you have a disproportionate outcome from a particular input. It's paraphrased as that 80% of your output comes from 20% of your input. Also, 80% of your sales come from 20% of your customers. 80% of your headaches come from 20% of your customers. I had this discussion with my wife last night. We're trying to set up carpools for the year. And we haven't even ever met this person, but she was already being bitchy and mean in email. And I said, she's the 20%. She is out of here. If it's this difficult and we haven't even driven day 1, we're not doing it. Your recommendations, you want something that's got bang for the buck, right? And so the problem, of course, with academic research like I'm used to, we thrive on tiny little fiddly noodly details that nobody cares about. Just a little tiny refinement of something. You want big bang for the buck, especially if you're a consultant to an external company and you want them to hire you again. You want to make it justifiable in terms of what you're doing. Okay, next point. The data that you have worked with, the data supports the story. I talk about analysis as a narrative. You're telling a story, and you need to use the data, but it's not sufficient. You guys may remember good old Pablo Picasso had this to say: computers are useless. They can only give you answers. What he's specifically talking about there is like calculations, right? They can give you the numbers, but the numbers are nowhere close to sufficient in and of themselves. Data doesn't tell stories. That's something that people do. It's inescapably, unavoidably a human action to interpret and implement the data. And that's something that you need to have a good understanding of what your client's specific and big picture goals are, so that you can couch your recommendations in their particular goals, their motivations. Also, data can, I say this to my students, I say the numbers are important. They inform the story. They don't tell the story, but they inform it. Similarly, they constrain the story. They keep you from getting too far off track. Okay, that's an important thing. So the idea here is that whatever recommendations you make to your clients should be based in the data, and you should be able to refer back to the data. I suggest that you drop this market and this product completely, and here's the data that shows that that's a poor use of your time. You got something much richer over here. The connections need to be logical and believable. They need to be able to follow it. This does not always work. Interestingly, there's a wonderful article on this that talks about like the single most important quality in a data scientist is empathy. It says you need to understand what your client needs, and you need to understand how your client will react to your recommendations, how they will implement their recommendations. You know, plus there's the eternal thing, you know, have you ever, maybe you've dealt with places that had pretty serious office politics, and you know that making a recommendation is going to be, it's like throwing a little ball in there, and you're going to have some idea of how that's going to play out. I like to think of this in terms of storytelling, in terms of movies. You guys may have seen the completely lamentable film Prometheus by Ridley Scott. Did anybody see this? Oops, I'm jumping ahead. It's a super crappy movie. Ridley Scott's a good director, and this was a high budget thing, and I watched it, and I was really hopeful for about 10 minutes, and then I'm going like, what is happening? Oh my goodness, it's getting worse and worse and worse. It's a great thing. You get on YouTube and type in plot holes in Prometheus. You know, get videos of people rambling them off as fast as they possibly can, everything that's wrong with it, and there's a sequel coming. It's going to be out soon. I have no idea how this starts out. The point of this is, I look at this as like, no person in their right mind would ever, you know, go into this building without sending some, you know, things first. They wouldn't take their helmets off without, you know, there's so many problems that have it. But it's not because it's on a spaceship far away. You know, people are willing to believe that. Avatar. It's 10-foot tall, remote control, you know, biological androids, but you buy into the story because it still is primarily about human needs and motives, whereas Prometheus, you just like, what is that? You know, what's funny about that is, again, is in my field in experimental social psychology, we talk about the difference between what's called mundane realism and experimental realism. Your study does not have to look like a normal situation. That's called mundane realism. It simply has to be emotionally involving to people. That's experimental realism. So were they engaged? Regardless of whether it's this completely artificial task in a basement lab somewhere, were they engaged? And mundane realism is not sufficient to induce it. You know, I think another example, a movie I hated was, did anybody see Hachi with Richard Gere in it? It's a dog movie. It's based on a true story. So you know what? It's a true story, sort of. I mean, it happened a long time ago in Japan, but it's a true story. Therefore, it should work. I hate Richard Gere. And I cannot buy him ever showing emotion for anybody or anything. Plus, he's his professor. And I can't tell quite what he's a professor of, but he has these dark wooden, you know, hallways, and he's off sword fighting with his colleagues during break. I go, I'm a professor. I've never seen that stuff happen. And so I just look at this is the most, I just don't buy it. Now, the point is, you don't want to present the results of your study and have a person go, wait a second, how did you get from this data point to that conclusion? And what on earth makes you think that conclusion would work well in the real world? And that's where you have to think about, again, the idea of empathy and buying into what's important to them and also how it's going to play out both within the company and with their clients. Nick?
Sorry, real quick on NPR yesterday or the day before, they were talking about suspense and how they can now program AI to follow suspense within a movie and be just as accurate as the humans saying, this is getting more and more suspenseful at these certain plot points and everything else, right?
Mm-hmm.
But the computers, the AI still can't determine empathy. And so if it doesn't understand that this character, that you don't want to see this person die or whatever else, then it's way off, right? So,
You know, by the way, it reminds me, see, the perpetual project of trying to get computers to understand humor. And it's a horrible thing to be a scientific researcher of humor because people feel you're killing the subject and analyzing it. There's a lot that goes on, but I'm not going to deal with it. Okay, gets us to the next thing. I like this one. Beware hubris, or unreasonable pride and confidence. You guys may remember this from 2000. Sorry for the grainy picture, but apparently there's nothing over 400 pixels on the internet for this. Remember when Al Gore was declared the winner of the presidential election back in 2000? I was teaching at BYU, and I remember this happening in November because I made a bet with my students that if Bush won, I would buy all of them donuts. I have to get like 12 dozen donuts. But if Gore won, they had to buy me donuts. We did not know who won the bet before the semester was over. So no donuts for anybody. You know, of course, that it went according to the U.S. Supreme Court to get the decision. The problem was a lot of people were calling this one. They were calling it based on early returns and calling it because they like this person feels presidential. And that's not what does it. Don't act more certain than the data warrant. And when the data are extraordinarily close, you're going to have to be very, very cautious. And I've said this before. I tell my students every single semester, I'm willing to bet that we will have several more elections where the popular and the electoral go different ways in the next 12, 20 years. Because I believe nobody's going to screw up like the Romney campaign did again by using biased and inaccurate data. Everybody's going to be using much better data, paying a lot more attention to it, and consequently going to end up with much, much closer races. I'll go on record for that, except there's the Hillary thing. I don't know what's going to happen. Anyhow, yeah, we'll see. Maybe it'd be Donald Trump. Anyhow, don't act more certain than the data warrant, which leads to this one, quantify uncertainty. Now, what that means is you have to give your clients some impression of how much variability there is in the data. Now, it's true that if you're working with enormous data sets, things might be very stable, at least if you're doing you wouldn't do inferential testing if you had millions of observations. But you need to adequately categorize the variability. So when people say something like, boys do better than girls on standardized math tests, it communicates the idea somehow that all boys do better than all girls, and that is not the case. Back when I first saw the data, the difference was about this big. The distributions were each about this wide, and the difference was about that big. It was a very small difference. It was statistically significant if you did an inferential test, but that's because there were millions of people in it. But it was a very small difference. Plus, people also tend to overlook the fact that boys are, and they say, well, so many more of the math geniuses and are men. I say, well, so interestingly, are more of the mentally retarded people. The distribution seems to be a little wider for men than it is for women. On the other hand, I've also heard more recent research that says, you know what, there just is not a difference. It's just not there. The difference remains for verbal, where girls do better than boys, but they're saying the math one just isn't there. It seems to have more to do with the availability of math classes and participating. The quantifying uncertainty, have any of you done Bayesian methods before? Okay, it makes a difference because in that you specifically have to put in, factors relating to confidence and to uncertainty in the Bayesian methods. If you guys remember, Nate Silver of the 538, who accurately predicted every single state in the 2012 election, he nailed it perfectly. And he did that by using Bayesian methods on existing polls. But he said you specifically have to quantify the uncertainty, or you can get led astray and feel more precise than it really is. It's the same way, like I tell my students, it's you got data from 12 people, you don't calculate the mean to 14 digits. You know, I don't know if you calculate to any digits because the data don't justify it. Also, while we're at it, do a sensitivity analysis. Any analysis you make is going to be based on certain assumptions about the data at hand and about the business model that your client uses. You need to see how much your things change when you modify some of those assumptions. And that can include, what if we had a little more variability in the sample? What if we had a little more of this group of people, a little bit of this group of people? But then you can also go back to the business model. What if the price of producing this widget doubles? Or what if the cost of shipping and tariffs changes? Then how am I going to change my recommendations? And this is where having a little bit of economics can be a very handy thing as well. So sensitivity analysis. Now, in terms of actual presentations, one of my favorite things is be minimally sufficient. The American Psychological Association actually has this in their recommendations for conducting research. They say, when you're choosing your statistical method for analyzing the data, use the minimally sufficient method. Use the simplest one that works. You guys may remember this line from Albert Einstein. He says, everything should be made as simple as possible, but not simpler. And I'm talking about in presenting your results. You may have done an extremely sophisticated and nuanced analysis because that's what it needed. But the presentation, now it may be that you have to reflect some of that nuance in your presentation. Include it when it's necessary. You guys remember there's a little recommendation from, you guys know Edward Tufte, maybe. I'll show you stuff in a second. Edward Tufte hates PowerPoint. I feel a little bad about using PowerPoint. But he says that the Columbia Space Shuttle explosion that happened in the 80s, he says, may be partially attributed to the fact that the engineers were using bullet point PowerPoints to communicate the information when that was not sufficient to communicate the complexity of what they were dealing with. Yeah?
They just also use the word significant over and over in the same.
You know, I'm going to assume they did. I haven't read it, but I do know the problem also is that significant means very different things to real people and to analysts. And so you run into that. That, by the way, gets back to the issue of empathy. You know, how are people going to understand it and interpret it? So make it as simple as possible. On the other hand, I love architecture. This is Ludwig Mies van der Rohe, who back in the 60s developed sort of the international style, or actually made it very popular. The glass and square buildings are all, you know, descendants of his. And he co-opted a phrase from the poet Robert Browning, less is more. He really brought that back into public awareness. So simplify, 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 which actually is quoting Strunk and White. So less is more. So how does that work in terms of your presentation? More charts, less text. Text is generally bad because it requires people to pay attention to something. And you guys all know visuals tend to be very information rich. Okay, charts are good whenever possible. Simplify the charts. Try to make them as clear as possible and draw emphasis to the parts you want. I'm going to show you more on this in a second. In a presentation, you want to avoid tables of data. I know this because I have students who put them up, like these enormous, giant things. I have no idea what's up there. Put them into reports, okay? It's a good idea. If any of you ever read a research report in Science or Nature, okay, you know, these are extremely prestigious journals. The reports tend to be really short, you know, like a few columns. And you're doing your best to get out as much of the critical information as you can. But what's become standard practice in the last 10 years is then to provide links. You know, here's more stuff, and then you go on that, and then you got like the 1,000-page report there. But you're making this, the report really becomes the abstract for the online materials. But avoid tables, keep it simple. And I'll say less text again, because this can mean a couple of things. Number one, try not to use bullet points, even though I'm using bullet points to show you that. Try to keep it as small, as few as possible. Try not to go over one line. I'm using, I want to say this is 150 point font. It's big. It's big enough that I can read it on this. That's important. By the way, I learned something. This may not ever apply to you guys, but I make videos training people how to do things for a living. And something I was told a few years ago, they said is, you need to understand that a huge number of your people are going to watch their videos on the phone, on their phones. So anything you do has to be readable on a 3.5 or 4-inch screen. Anyhow, so I want to give you a few examples of, yeah, Pat.
One thing I was going to add to that too, kind of, is I love the more charts, less text. The one thing I'd add is there more talking, or in other words, make the explanation, because you're completely right. More charts, less text, but don't just give a chart that here's a nice big pie, and this one's red and this one's green. You have to explain it afterward too. So
yeah,
the talking part of it is the key also as well.
Yeah. Plus, you guys know the cardinal sin of PowerPoints, and that is turning your back to your audience and reading the slide because you never saw it before. I told my students, you turn around, you get an F. You're just done. Which is why I have both my computer here and my phone. And also the idea is don't put paragraphs of text on here. These are talking points. You're going to explain them, okay? And again, it also works if you have a written report. You can give all the details in writing in the report. Theoretically, you're going to have both an in-person presentation for the question and answer, and that's all the executives are ever going to see. But you're going to have a detailed report as well. You can go into a lot of information there. A few examples from Darkhorse Analytics. I showed these a few months ago at at one of my other presentations, but they're wonderful in terms of organizing your information. And I don't know if these are GIFs that I've put on my thing. We'll see if they work. Okay, they had a blog post. These are all from their blog, Darkhorse Analytics. This one, data looks better naked. Let's see if.
T-shirt.
Yeah, there's your. Oh, there we go. It is running. This one's about how to clean up a bar chart. And you see, they're just removing. And the thing is, what they're starting with is pretty close to the default for Excel. And, geez, they're not done yet. I keep the lines in. That's the only difference. I would have stopped one sooner. I wouldn't have put the labels in. But there's that one. Now let's go to the next one. Salvaging the pie. I know I showed this one to you guys. Okay, will it run? Do I have to press something? There we go. You guys remember this one? Because we like to make fun of pie charts, right? The one time you would include a pie chart is when your client has a template and requires it, right? Sometimes it's just part of the institutional practice. Then you do it. Here's the best part. The way to fix a pie chart is by getting rid of the pie. And look, they tricked us. It was a bar chart the whole time. Okay. Incidentally, they have one here about radar charts. Has anybody here ever made a radar chart? You wouldn't want to admit to it if you had. This is a radar chart, right? So you got stuff. The problem is a lot of designers like circles. Circles kind of look cool. And what they have here is a whole bunch of different countries. And the data here, by the way, I have no idea if this is real data, because Darkhorse tends to make up their data. But the idea here is estimated and ideal pay ratios of CEOs to unskilled workers in 40 different countries. And the idea here is that, like, somehow in South Korea, people say it's great if the CEO makes a ton more money than the unskilled workers, whereas in Norway, there's like no difference at all. Okay, right? I think this is artificial data. That's a radar plot. I've seen them. They're neat because they grab your attention. Because you look and say, like, what is that? Well, they say there's a couple of problems with radar plots. They said, first off, as you go out, the perceived value does not increase linearly. It's closer to a square. This one, even though the values are, 3 times higher, it's about 4 times as much space over there. And then this one, they say, and the order in which you plot things makes a huge difference. Like the countries,
See, this one looks big, that one looks like an outlier. It's the same data in all three of them, just different order. They said, now you can put things in order, and then you end up with a bizarre little seashell that's kind of hard to read. Again, don't do it. And they said, well, really, this is one, just go to a bar chart. Bar chart's good. By the way, this isn't really a stacked bar chart, because it goes this is the ideal starts here and goes to here. And the estimated also starts here and goes up to here. So I think it's a valid use. But, it's easy to deal with. They have another one here called When Small is More. And I mentioned this before, but the idea here is you can get a stacked line chart, which I imagine there's a situation in which it makes sense, maybe. Because what you're doing is you're taking all of the different, this is metadata, Viking revenues, they get it from plunder, loot, other pillage, raid, and thief. And they get most of their income from pillaging, but this gives you the total income, right? So you can see how well they're doing on each one. And it's going across the years, but it's hard to see, for instance, is there how much of a change is there in income from plundering? Because the baseline is shifting all over the place, right? So what they're saying, and this is something that comes, I know, from Edward Tufte, is say small multiples. Just make several charts. Put them right next to each other, give them the same axes, give them the same scale, so it's really easy to compare them directly from one another. And you see, yes, pillaging is the most. And we had a big spike in plunder right here that you could not see.
Linda's fine.
Where is the spike? 2009. I think that's the spike. No, that's the spike. But you can't even see it, right?
Was it even the same data?
I believe it is.
So on this one, you're looking at 0 to 500 for the top of maybe 750. And on that one, you've got plunder that sits on top of it. So now it looks like, so go back to the other one. Now plunder looks like it's actually peaking out at 1400, right? And none of that
Let's look at thieving, because that one will be the same on both.
Okay. Nowhere near 250.
Maybe.
That's cumulative revenue on the stack chart.
Up here it is.
No, not the stack.
Oh yeah, it's cumulative from all sources.
Yeah.
And that works well, but on the other hand, you see, they also have just another one here that does say over time, what's the cumulative.
Right.
And so these 7 charts are actually easier to read than the one chart, because there's less disentangling that you have to do. Anyhow, the idea here is don't be afraid to repeat it. Small multiples show up in a lot of places. It's a good way to do things. And one of my favorite ones from them is what they call clear off the table. And we'll see if I can name it. Maybe. There we go. This is what an Excel chart looks like, right? Table. And it's just this gradual process of simplification. So, what's crazy is how much of this, you have to go through all this work to get something that's that much simpler. The idea is hopefully you can save it as a template, but we're still not done. I don't think it's great. And there you go, that's it. So one more thing I'll talk about is Tufte, Edward Tufte, Mr. Data Visualization, modern father of data visualization. Talks about decoration versus line, because a lot of people like to make this stuff fancy. I actually studied industrial design. I've mentioned this before. I took drawing classes and color theory classes. And as a result, you might think, I know not to make stuff busy. This is a chart that is not from USA Today. This is from the New York Times in 1978 when things were groovy. And so this is 1978 where they're trying to show federal regulations for, and here it says, this line, which in the original chart was 0.6 inches, represents, 18 miles per gallon. And then somehow, this one down here, which represents 27.5 miles per gallon, which is only 50% bigger, is 10 times longer. So it calls, and Tufte calculates what he calls the lie index. How much is this lying to you and misleading? This one is doing it massively. And it's from the New York Times, which these days is held up as the sort of the pinnacle of responsible graphics in journalism. You guys held a paper copy of the New York Times in your hands recently? You get one and flip through the whole thing, especially through the financials, because the charts they have are amazing. First off, they're beautiful. They're beautifully done, and they're usually very easy to read and informative. They're great. So Tufte takes the same data and says, well, no, this is the same stuff. See, oh, by the way, I'll point out there, for some reason, the years are not spread out in a uniform way. So here, he says, this is one way to do it. I might have done a bar chart, but this one works fine. And I like, he says, on the other hand, maybe you just, cringe and everything's be too pointy. He says, so if you want to decorate, you can do this. And you get decoration without lying. So I'm trying to find a way to incorporate that in my other presentations. By the way, these are straight from the book. I actually got my copy of the book out and took photos of the charts, because every time I tried to scan the book, it pushed the off button. Wonderful book. Tufte has 4 books. All of them are treasures. They're fabulous. But back to the idea of your overall presentation. The goal of your work that you have done for your client, the whole project, the goal of the whole project is clarity. You're trying to get clarity and analysis, where you are performing an analysis that takes a very muddy, overwhelming, confusing set of data, and you're finding useful patterns and regularities in it. You're getting clarity and analysis. You're getting clarity and expression in the way that you communicate it to the people. And you're getting clarity in action, where they now know what they should or should not do as a result of your analysis and your presentation. So, to return to our friend Hugh Billington, who is now reading your research report, he says, take that report, make it swing. Your clients will sing your praises.
Awesome.
Questions?
Any questions?
Can't be the only one that
Yeah,
had questions
Brad.
the whole time.
So, I was at a conference. I went to a session where they were talking about presenting, charts specifically. And they gave some really good, they had that line one there that you had.
Yeah.
But they went through and they talked about, like, oh, hey, you want to have your colors doing this so that they don't have to figure it out, and it shows you. And here's when to use a good bar chart, and here's when to use these other types of charts. I took notes, but I'm thinking there's got to be a place you can get more information about that type of stuff.
Well, okay, ready? Here's the problem. Most resources on data visualization spend a lot of time talking about very complicated charts. So as much as I like Tufte's books, he does spend a lot of time. There's this one that shows up a million times, it's Napoleon's March into Russia and back.
Yeah.
You can buy, high quality lithograph. I still don't know how to read the chart. I've seen it 100 times. I know vaguely what it's telling me, but I don't know the specifics. It's hard to read. I'm willing to say, you talk about the 80-20, and I think I said this last time, I'm willing to bet that about 98% of the data that you need to show people visually can be done in bar charts, histograms, scatter plots. I think the time, and those are so easy to read. The times that you need more than that are going to be, I really think, are going to be very few. It's true if you're doing a cluster analysis, you're going to have a dendrogram, but those are easy to read. People, especially, and when I do a dendrogram, you guys know a dendrogram, the icicle plot, and I get it there, and I have the R code that then draws boxes around it at a particular level. This is the level of clustering that you're interested in. This is your maximum bang for the buck, right here. Don't go all the way to the bottom, because then they're all separate. Don't go up here, because then you have one group. Right here is the sweet spot. But you know what? I have never used a dendrogram in a research report, never. Because they never came up to me with a clustering question that needed to be reported in that way.
So
And I want to throw into this too, because Nick and I have done a lot of the competitions and everything else. I'm glad you're very aware of those. But one thing that we learned more than anything else is that when it comes down to this data and this visualization, when you're doing the data science, the data analytics, or anything else, it's about the story that you are presenting. It is the story that you are presenting. It's not a matter of the best looking chart, the best looking visualization always. It's about what you actually tell them that works and what does not. Because in the end, that is the value behind the data.
Well,
So, you know, it's as much the charts as it is the story as well.
and that's an interesting one, because most of the time when you talk about data competitions, you're talking about predictive analytics, like the Kaggle competition. That's with a very clean data set with a very, very well-specified goal. We're trying to reduce the, for instance, the root mean square error. You know, and whoever does that wins. The global data competition does not have this as the outcome. It's about, here's the general topic, find some data, tell a compelling story that leads to something. And so it does get directly at this.
And I find companies when they come to me or anything else, or when I'm doing this, I'm telling stories. It's not just the data. Sure, we have common reports that they always see the pie charts, the bar charts and things like that. But it's also, when do I give them a story that actually produces, now you're going to stop having this happen. A good example is our company worked with JetBlue. JetBlue changed its prices and items and where they put people in seats because of our recommendations, because seats kept getting complaints in those certain things. They were able to analyze it. It wasn't because we gave them a pretty chart that said, this is what your seats look like. It was because we told them, this is what the data is actually telling you. So, go ahead.
So, what if there's an issue with building the story? For example, what if the relationship between the data and the recommendations isn't necessarily clear? Just as I'm making up an example. What if you're doing some sort of analysis on sale or whatever? You say, okay, men greater than 16-year-olds tend to buy a lot of shaving cream. Well, that's a clear connection. You should definitely be marketing your shaving cream to men or whatever. What if your analysis comes back and says, okay, we find that women between 42 and 43 are buying lots of shaving cream, but we're not sure why. Or even more, what if you're doing some sort of like deep learning analysis, and in fact the connections are totally opaque and you have no idea how you got from point. What do you do with that?
Well, in a deep learning, you're usually not telling a narrative. You're just able to say, this mechanism works better for classifying photos. You know, this one is more effective, and we don't care how it got there, as long as it works well on both our training set and our test set, and it works well when it's implemented. And again, that's where it's okay to be opaque. But that's because you're not consulting, you're giving them the product. You know, say, this is it, stick it onto the server and run it. On the other hand, when you're talking about something like marketing, that's never going to be divorced totally from the human decision makers. And that's one where also a nice way to couch it is to say, the data suggests this. And it suggests that if you do X, Y, and Z, it will lead to A, B, and C. But it has to be put as recommendations, because unless you work for the company and you have personal experience with their product and with their method and with their discipline, they're going to know more about how something's actually going to work than you do. It's kind of like, I have to tell you, I would be loath to tell a top-level salesperson how to do anything ever. I'd say, you're the one who's been selling, you know, $25 million of product a year, and you know how to move your market. That's why they're paying you, you know, these extraordinary commissions. And so that's one where they have a depth of understanding that I just never will. And then the idea about, what about when you get these weird little blips in there? The way I usually handle this is saying, this is a weird blip. I don't have an explanation for it. And ideally, if you have a large enough data set, then you can do some sort of, you know, splitting and saying, you know what, that only shows up because of like these 14 cases over here. It doesn't, when we split it up any other way, that doesn't happen. And hopefully, if you've got a large data set, you have enough other variables that you could use theoretically to explain the blips. But a lot of them, on the other hand, if you can show that it's stable, you've identified a market and you can sell to them. Yeah, Brad.
There's a funny story along with that. Some of you guys know Christophe Girard. He used to be data science lab director at BYU, and he spoke to a couple of these. But he teaches a class of machine learning, and he talked about in the class, the students tackle a real world problem, and then they present the results at the end. And he told about the students that worked for they did this thing for the bookstore, and they came back with this really just all excited. We found this awesome correlation between buying product A and product B, and it's just like amazing. People always buy these two together. This is really, really cool. And they did that in their presentation. The bookstore said, yeah, because they're packaged together. They always resolve it that way. And so the point he was making is that you don't just like take the data and run and work on it, come back and then give the presentation. If you see things like you're saying, then before the presentation, you're talking with the, hey, I'm seeing this kind of weird thing. Do you know what this might be? And just keep involvement all along the way so that you can kind of help to explain this.
Plus, I'll just mention for what it's worth, in the research that I have done in my academic discipline, there's so much noise in the data. You're asking somebody to fill out a questionnaire. There's so many things that can make their answers higher or lower at one point. And so often they just don't understand the question and they're putting down something totally random. I've had this completely pull the rug out from under major paid projects. It's like, oh, nobody understood the question when that was our central variable. People didn't understand it. But that's also with the small data set. And that's also, if you're using something that's like, web clicks, those are unambiguous, that's nice. I was going to say something else, but I can't remember what.
I wanted to mention something on that too. I like how you brought up movies, because I think movies are a good key. You want to keep your audience in mind, right? I went to the Broadway theater a long time ago, and the Imitation Game was in the theaters, and we wanted to go watch that, and they were like, you don't want to see that, you don't want to see that, watch this movie instead. And it was this French movie about a girl who was relatively suicidal because she thought she was going to lose her job. By the end of the movie, she lost her job and was happy about it. That was the movie. You've seen the movie, right? There was nothing to it. And there's a lot of French movies like that are like deep learning. You have no idea. It's very opaque. I don't really know what the meaning is or why I actually spent my time watching this.
Yeah.
Right?
Then a miracle happens.
But if they knew my interest, then Imitation Game would have been the obvious suggestion. Right? Get to know your audience, ask a lot of questions. Somebody asked earlier, you asked earlier, what questions should you be asking? Just think about who, what, where, whens, and whys, and just keep asking why until you really understand what it is they're really trying to accomplish.
Actually, maybe I brought this up before, but my wife is a modern dance choreographer, and she was a teaching nurse with the Lincoln Center Institute back in New York City, who would send artists out to schools to try to get kids to engage with works of art. And they did an enormous amount of research and found out there was this one magic question to get kids to engage with the work of art in a meaningful way. And then as you say, so what do you think? And they go like, stupid, love it. And he said, so that's nothing. It's just extraordinarily rough, evaluation. And they said, what makes you say that? And they go, because it's stupid. Well, what makes you say that? And what they said is, you have to ask the question like 20 times. And eventually, the kids become reflective. And they say, what is it about that work that caused me to feel this way? And what's interesting, they say, what makes you say that is different from saying, why do you say that? Because what makes you say that focuses on the externalities. It's focusing on that. What about that over there makes you say that? And that's fair when you're doing data. What about the data makes you say that? As opposed to why do you say that, focuses it back on the person, they become defensive. So it's an interesting one. If you're giving a presentation and they don't believe you, then you have to be able to back up a little bit and say, well, it's from this analysis. Who knows? Maybe if you're prepared, you've got your research report with you. It's on this chart right here. I can talk to you about it later.
So if I can summarize for a bunch of different things, I'm trying to generalize it a bit. I heard be transparent about not knowing how you got the result necessarily.
If you don't.
If you don't use the terminology like the data suggests this, that may lead into more investment for more research or something along those lines. We involve the stakeholders to say, hey, I'm seeing this anomaly. What do you think this could be? Trying to get some external opinion before you present. Know your audience, know what specifically would be interesting to them. You don't necessarily even have to say that you don't know how to pick up this data point. You just have to be able to point and say, this is the question they want answered, and this is the way I did it. And getting point A to point B might be something we did an analysis.
Yeah.
Is that
You're not going to explain your predictive analytics model to them. You're just not. You might mention, we used this and this.
Or there might be 3 data scientists in the room or something that actually want to know, but otherwise, if you're talking to business stakeholders, they don't care, typically. It really depends. It's all about knowing your audience. I mean, again, Nick and I fall into this too much when we see the competitions, like you said, the global data competition, or when we did the predictive analytics, when we did it with Skull Candy and Health Equity. The people that were in the room were not asking us, what predictive model did you use? They were asking, what did you find? What were the results? What was the answer? What do you want us to do? Those are the things they want to know. Now, sure, this group would love to know what model you used and how you did it and those sort of things, but it's knowing your audience.
Okay, maybe I have a, maybe there's some unique use case, and if it's not, please shoot me down, because I would love to be corrected on this. But in my case, we do analysis for large data sets that are primarily interesting to physicists, things like what was the atomic weight of these molecules and that sort of thing. The business team has, or not physicists, they have no idea how it works. They don't care at all from that regard, except that there is regulatory pressure such that the way we got from point A to point B has to be very well documented, because there's legal ramifications if it's not.
Yeah.
So they are only interested from that standpoint. Hey, this new model is great. You used what sort of thing to get there? And it's totally opaque. And well, yes, but that's state of the art, and that's the way it's done everywhere. So maybe that's even a different problem, but
Well,
I'm not sure how
you know,
message that sort of thing.
strangely, it reminds me of this giant training we had at my university on interviewing job candidates.
Right.
And it says, there are certain questions you just can't ask. It says, and also there was this wonderful training that says, and what if you're the candidate and they do ask you this question? They say, well, you say, what you done is, they want to like, so like, you look kind of old and sick. You know, what you want to say is, if you're concerned about what, you know, I assure you I am physically capable of meeting the demands the physical demands advertised. Or if they say like, you look like you're 9 months pregnant, they say, I can assure you that I'm able to meet the, you know, whatever requirements you have. And I'm just saying nothing else except this is your requirement, I can meet it, and that's all you're allowed to ask. This one, so it just makes me think, what you need to do is address the larger question. Say, what you're asking that because you want to know if I'm going to be able to show up on time. And the answer is yes, I will be able to show up on time, and how I manage that is not your business. But for the salespeople, you can say, you know, they're not going to say, well, here is the documentation that explains the process. It says, it's complicated, it's opaque. On the other hand, I can also assure you that it meets the regulations that are in place for this. So you don't have to worry about the regulatory aspect. We've taken care of that, and it's documented right here, and it's assured.
Thanks. That's a great answer. I actually do. I can say so and so use these same techniques, and they've been approved by regulators.
Yeah.
Or other research.
Yeah.
Thank you.
Okay.
We're done.
Awesome.
All right. Oh, sorry. You got
I just want to stop it. Go ahead. Wherever it's
Oh,
at.
I may have minimized it.
There's another one there. There we go.